In this video, we'll be demonstrating how to do the tool offsets and workpiece offsets. So first, we want to take our aluminum rod and we want to insert it into the cullet. We want to make sure that about 1 inch is within the cullet, as seen here. Next, we'll go ahead and insert the cullet into the spindle. It's best to use both hands. Make sure when you're tightening the cullet, you are rotating the silver rod on the other end, and make sure you have the other hand on the cullet pushing it in to help suck in the cullet. Once it's tight, go ahead and use the wrenches to tighten the cullet and secure the piece in the machine. After that, we then want to go ahead and go into the Mach3Turn software, and we want to make sure that we first want to start off in the manual window. Once we do that, we want to go ahead and home our machine. So we first want to do set home Z and set home X. And those noises you heard in the background were the stepper motor is moving the tools to its home position. To make sure that it is home, go ahead and use the hot arrow keys, which for us will be the left, right, up and down arrow keys to control the axes. After that, go ahead and click on Home All. And the motors should move the tools back to its home position. After that, we want to then home the turret. So then we want to go ahead and click on Reference Turret. And it should move the turret until it reaches tool 1, which is our right hand cutter. And you will notice here that this DRO here is representing the turret in degrees. Once it has finished its operation, we then want to go into here, click in the box, and then type in the code T010. What this code is saying is that this 01 here is the tool number we want, and the 01 is the offset we want with the company the tool. Go ahead and hit enter, and the turret should then move to tool 1 and have that lock into place. Once that's done, we can go ahead and quit mode and quickly go to tool table so I can explain how we're going to do this. So for setting the tool offsets, this is the window we're going to be using. So for our tool 1, which is the right hand cutter, this will be our reference tool. So the X and Z offsets should be 0. As for our tool 3, that is going to be our left hand cutter. And because that is in a different point in space compared to our right hand cutter, we need to tell the software how far off it is from the point of reference. So for this example, the offsets is already been pre-programmed to here. The offset for X is displayed here, as well as the Z. Same thing for our tool 5, which is our parter tool, and for tool 7 for our thread cutter. So the way we want to do this is first we want, for using our tool 1, we are going to reference the tool off our piece, which we're going to quickly face the front end of the rod, and then say in this window this is 0 and 0 for our Z, and then we want to click touch X and touch Z to tell where our offsets are. Since this is our tool 1 and this is going to be 0 and 0, the offsets here will be 0. When we go to tool 3, this should be 0 and 0, but then we're going to go ahead and move the left hand cutter tool to roughly to the same point where the right hand cutter was. And once we find that point in space, we then want to click touch X and touch Z, and the difference that was in this window here will then be transferred to the offset windows here. Once that happens, this will read 0 and 0 for tool 3, and when we go to tool 1, it will demonstrate the offset that it was for this tool. With that in mind, we'll go ahead and do a quick demonstration. But one last thing to note is that when we type in the spindle speed that we want, which is going to be 2000, we're going to get this message saying that PWM bumped to minimum setting. that means the spindle should go up to the minimum value that we have set in the software. But unfortunately, there is a small problem with the issue. It sometimes happens and sometimes not. So we hit the spindle motor. You can hear in the background that is not its true speed. And if we have a quick look, you can see here that it's not really rotating at 1200 RPM. So the best way to fix this is by, on the software, we want to go ahead and click on this arrow key once. And then you can hear that the spindle motor is now rotating at the proper speed for cutting. And to stop the spindle motor, just go ahead and click this X. And one last thing to note, if you're going to be doing any cutting into the material with any of the tools, make sure your jog is at 10%. If it's not, then go ahead and click in the window and type 10% and hit enter, and it should give you the value. So with that in mind, we'll now go ahead and demonstrate how to do the tool offsets. So when doing the tool offsets, we first want to go ahead and face the front of our stock. And then after that, we then want to bring the tool up so that's just about on the top of the circle. And then on the software, we're going to say this is our 0 for Z and X. So I'll quickly demonstrate. Go ahead and turn on the spindle. After that operation, now we have the tool right where it needs to be for measuring our tool offsets. And on the software, I've inputted the values of 0, 0 for our X and Z. After that, we want to go ahead to quit mode, and then we want to go to tool table. And in this window, make sure we have tool 1 entered. And make sure that this is 0 and 0. We then want to click touch X and touch Z. And that is what we got for our tool 1. So now to do the remaining tools, we're going to go back to tool manual. And then we're just going to simply move the tool turret slowly away from the stock so we have room to rotate the turret. Once that is done, we are then going to go ahead into this window and type T0303 and hit enter, and that should rotate the turret to tool 3. So this is roughly where our tool 3 would be, in the exact same place as our tool 1 would be. Once we have determined that, we want to go ahead and go back to our software, and in the tool table window, we want to make sure that we have tool 3 in this window. And then once we again have the tool roughly about where tool 1 was, we want to go ahead and click touch X and touch Z. And as you notice, as I click those buttons, these turn to 0, and the offsets were then transferred to these windows down here. And this is just going to be the same process for tool 5 and 7. For tool 5, this is roughly where it will be, approximately to the right-hand cutter. Once we have that, go ahead and use the same process to program in the tool offsets. And that would be the approximate area for tool 7. Once again, go ahead and program the tool offsets using the same example that we did for tool 3. Once you have done all the tools, you can go ahead and go to tool table editor, and you can scroll down the list, seeing that all the tool offsets have been saved into the computer. Once you have verified that they are in and they look about accurate, go ahead and click apply and click OK. With that, then we are ready now to go ahead and mill our part, to turn our part. To do that, we want to go ahead and go back to manual. Make sure we have the machine homed. And then we want to type in tool 1, so T0101, hit enter. And now we're ready. So using our right hand tool, we're going to go ahead and face the front end of our rod so we can determine the coordinates for our workpiece. Once again, you want to go ahead and turn on the spindle and then click on the increased spindle speed key to get it to full speed. Once you're done facing the front of the rod, go ahead and enter 0 for the Z-axis while keeping the right hand cutting tool on the face of the rod. For the X-axis, we need to face off a little bit of the surface on the rod so we can have a nice smooth surface for measurement. After we do the facing on the circumference of the rod, then we want to go ahead and use a micrometer and determine what the diameter of the piece is. So after taking the measurement of the micrometer, we can see that the rod is measured to be 0.992 inches. And for the software, we want to punch in the radius of the rod. So we took our measurement, we get about 0.496 inches of our micrometer. Please remember that these big numbers here represent 0.1 inch, and these little tick marks represent 0.025 inches. And this little rod here represents 0.001 inch, and for every full rotation, it represents 0.025 inches. Now that we have measured the radius of our piece, we want to go ahead in this window, click, and then enter what our radius was, which was 0.496. We hit enter. Once that's done, we can then go ahead, click Home All, and home our machine. Once that's done, we can go ahead and click on Quit Mode, Auto Tool, and this is where we can load our G-code. We just click Load, locate the file you want to do, click on it. It will open up into the window and generate the G-code reference. Go ahead and click Cycle, and then start cycle. One quick thing to note is, again, that once the spindle motor activates, be sure you click on this arrow key to get it revving up to its full speed. And every time it finishes a turning face operation, you have to click cycle start again in order for it to move on to the next operation. Thank you for watching.